This is Algebra 2, lessons 87 and 88. Notice on your syllabus, there's only one problem, two problems from lesson 87. The practice problem and problem 7. That's it. It's slope. You should have heard slope a whole bunch by now, a whole bunch. So we're going to talk about slope and distance together. How are they alike? How are they different? All right, what is the formula for slope? That's right. It's the change in y over the change in x. I wish my hand would listen to my brain. Or, remember, what's always in the numerator? Y. Y is always in the numerator for the slope. We could write it y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What does this slope tell me about a line? If it rises or it falls, and how steep it's going to rise, or how flat the line is, or if the line is vertical or if the line is horizontal. All vertical lines have an undefined slope. If a line is vertical and it's like x equals 4, it has an undefined slope. If the line is horizontal, the equation is like y equals 2. The slope is 0. All horizontal lines have a 0 slope. All vertical lines have an undefined slope. This line would have a large negative slope. That line barely rises as it runs, so it would have a small positive slope. So the slope tells me visually what the line looks like. It is different from the distance because distance tells me, so slope tells me rises or falls. The slope tells me what's the length of it. How long is it? From point A to point B, what is the measure of that line in between those 2 points? Now, the formulas are very similar because it's the square root of the change in x squared plus the change in y squared. Well, what's the change in x? Yes, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. When I square what's in these parentheses, what kind of a value will it always give me? Yes. Yes. So if this number is negative 9, when I square it, it's going to be positive 81. After you square these, you're always, always, always going to have a positive value. All right? All right, so let's work 88.1. We're going to find the distance and we are going to find the slope for this set of values. Okay, here are my end points. Well, maybe. I keep finding them and then losing them. All right, 4, negative 2, and negative 5, 3. Guys, they're coordinate pairs. One is x, one is y. Label one set 1, label one set 2. I don't care which one you label. You can label the first one's 2 and the second one's 1. It doesn't matter. You're going to get the same value because we are literally looking at the distance between those x values. Okay, so before we put these numbers in, What is the distance if you're just thinking a number line, between 4 and negative 5? What's the positive distance? 9. That's right. What's the positive distance between negative 2 and 3? 5. Right, so we're looking at like the absolute distance. All right, but we're going to plug it in. We do x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that's the square root of negative 9 squared plus 2 negatives make a positive, so it's 5 squared. Isn't that what we said the absolute distance was between those two values? What's negative 9 squared?
81.
81 and 25? 25, I'm at 5, is 25. Added together is 106. Can that be simplified? I know 2 goes into it, but that would be 53. I don't think that would, so that's the distance. Literally, that's the length. What two values is this between? 106 is between what two integers? 10 and 11. You know how you got that? Because square root of 100 is 10. And square root of 121 is 11. So it's between 10 and 11. That's how long it is. That's the length of it. Now let's do the slope. The change in y is in the numerator. 3 minus negative 2 over negative 5 minus 4. That's 3 plus 2, which is 5. I almost said 6. Over negative 9 are negative 5/9. So then what do we visually know about the line? It's falling from left to right. We always read our lines left to right. Okay, we've taught, yes, go ahead.
Sorry.
No. Yep, you don't have a question? Okay. Now, we've talked about the ideal gas. PV over T equals PV over T. Y'all probably have not done any ideal gas in chemistry. Probably not. Okay. Have y'all done moles?
Yes.
Okay, good. Because the ideal gas formula actually has moles in it. So this really is the ideal gas formula. PV equals nRT. I'm about to sneeze. Thank you. No, I'm not going to sneeze. It's going to stay with me. Just kidding. What is P? Pressure. What is V? Volume. What is T? Did I add? I don't know why I put an N there. What is T? Temperature. All right. N is the number of moles. And R is a constant. Constant. It's 0.0821. It's sort of like pi. Except it's not, because it has a terminating decimal. Pi does not, right? But it is a constant that doesn't change in the ideal gas formula. Why do we have a constant? Because we have an orderly God. And this never changes. And actually pi never changes, does it? As the circle grows, does the value of pi change? No. As the circle gets smaller, does the value of pi change? No. Isn't that amazing? That is so amazing. And this constant, okay, my engineer boys would tell you there really is no ideal gas state. However, I argue with them every time. I'd say, so why are plants not exploding if there's not an ideal state? There's got to be some sort of close to ideal state, right, for gases. Otherwise, all of our plants would be exploding. So this is what we're going to use. PV equals nRT. So PV equals nRT. Say it with me. PV equals nRT. R, we already know, 0.0821. All right, we're just going to plug the numbers in and solve for the variable. That's all this is substitution and solving for the unknown variable. Look at 88.2 on page 366. So we're going to be solving for the number of moles. So we're going to be solving for N. And an amount of gas, when the temperature is 273 kelvins, I'm going to substitute that in for temperature, 273 kelvins. The pressure is 1 atmosphere. And the volume is 8 liters. How many moles? Well, I know what R is, 0.0821. So I just divide by 273 times 0.0821 on both sides. It's just algebra. How many moles do we have? Y'all do that calculation. Okay, remember you can't not do 8 divided by 273 times this. You cannot do that in your calculator. If you do it in your calculator, you do 8 divided by open parentheses because you're going to tell your calculator to multiply the next two numbers before it does division. What is it, Therese? 357. Okay, got it? So what are we doing? Simple substitution, solving for the unknown variable. The constant is 0.0821. Let's do example 3. I would say this is not rocket science, however, it probably is, actually. All right, so now we're going to find the volume. Now we're not going to know the volume, but I know that this is going to be 0.0821. I go ahead and write Rn. Find the volume of 0.832 mole. 0.832 is my mole number of a gas at a pressure, that's my pressure, having a temperature of 400 kelvins. Okay, so all I do is I divide by 3 on both sides and get the volume. All right, somebody get the volume for me. What's the volume? Remember, you have to tell your calculator order of operations. If you do the numerator, hit equals, and then divide by 3.